I have decided off camera that this is not what we should start with. It's already too complicated for a first solution. The complicated solutions should come after the skeleton solutions, the bare minimum. And this feed rate looks much more manageable to begin with. I've been looking at other Zectronics games and Zectronics style games, the so-called Zec-likes, and I have a few others right now. After I'm done with the two that I'm working on currently, I'll probably move to those, and then we can have fun making things in those. Now about this. The standard stamping mechanism would probably work with this, as long as the feed rate isn't too great. Like that. It's just barely too much for it to handle. In that case, I actually have an idea. What if we... what if we, quite simply cut the stream in half? This way, the two individual streams will both have half feed rate, which means they can both be streamed to different assemblers, the different stamps, which can both be fed to the output. And so that way we'll technically have parallel processing capabilities. I'm not actually sure how this would work though, or how well it would work. I know how it would theoretically work. But let's actually see. Looks good already. Currently. Oh, it is working. In that case, this is the finished product now. That's facing backwards though. A solution to the stamp problem, just half the feed rate. Or quarter it if it's really too fast. Could build walls with these. Now for the others. These should be simple. Yes. Nowhere near as complicated as that angled part. Linear parts are always simpler. You can just extrude them. And now, at this point, yes, the two can be put together very quickly and easily, as long as they're synchronized correctly. This needs to extend fully. And oh, yes, this needs to come in last. There, that's correct. And because everything is happening at full feed rate, I don't need to synchronize it manually. And now I just need to put these two together, and then it should be complete. Yeah, it doesn't look right. I'm going to need to make a setup for rotating these. And probably pull it in to make room for the rest. This move tool is very powerful. There. And now, these are actually both at the perfect elevation. And at this point, I can splice them together. I don't like having all of this unsupported, even if it doesn't require them. It doesn't look right. There. That looks better. Now, for this. I think it should just be as simple as that. One problem. Need to make sure that they are synchronized together, or in this case, the lower part needs to come in slightly after this part comes in, but it's not coming in fast enough, and so I need to delay this one somehow. Oh wait, this isn't correct. I actually need something like this. There. The reason this is so heavily delayed is because of how long it takes for these two to be completed. It's backlogged. I have an idea. What if these are just delayed? Or actually... move all of this ahead first in order to insert some delays in this line. So this is 5 units long. Place one stop there. Still slightly too slow. More forward. There. That should be just enough timing. And it looks like it. Yes, this is complete. And now it just needs to be rotated and fed to where it needs to go. There. And the elevation is here. There. Now it should be done. Yes. No more work required. And the footprint score is surprisingly good. So is the cycle and block score. Now, theoretically, I could cut out every other one of these. And in reality, that should work as long as there's no anomalies anywhere in the line. Wait. Oh no. I forgot there's a rotation there. So, actually, let's see how many undos it stores. Yeah, I would assume close to hundreds like I originally thought. In that case, we're done here. Next. Time for another promotion. More garbage. Eventually we'll just be swimming in garbage. Now, more work. Yeah. This bed doesn't have a pillow. How is that even a bed anymore? Just noticing. Very angular edges also. Enough of that. Next. You see, the problem with being a better engineer is that you get you get handed even more difficult tasks, and so if you're not still better. Hold on, I'm trying to focus. It's not a good idea to try to talk about something and focus at the same time. That's when you make errors. Now we need to harvest these animals. And of course, because these animals are inherently unpredictable, that adds a whole new layer to the machine and its complexity, which is pretty great. So we need to get them up there, which means we need lifters for all of these. Fortunately, they don't move when they're being lifted, or at least until the top, which is this level, which is perfect. Now just to make sure that they always go in the right direction. flow control. Now they can just jump directly off. I can tell this is going to be irritating. I'm just going to funnel all of them in the correct direction. This is all going to need to be walled. Oh, and something that would help, actually. Just to make sure that they don't linger too long in any one area. There. This is the phase 1 area, which works great. Now we just need to bring them to the packaging plant, and then evenly distribute them between those 5 outputs, which is difficult because the number of outputs not only is not a power of 2, is a prime number. Thankfully it's a small prime number though. If it was a large prime number that would be even more of a problem. Yes, this all looks correct so far. Perfect. Technically, this already solves 1/5 of the problem. Oh, I know. I know exactly how to make a good distributor. What am I even talking about? And it's perfectly extensible. And you can't say the word perfect very lightly in most cases. Or in fact, I would think any cases. There. Routing should be good enough. I prefer for it to look better also. There. Now bring them in. This will split them evenly between the 5 outputs perfectly. And it has a very high speed limit. There. The cycle score is unnaturally good, the footprint score is horrible, and the block score is average. I can actually increase the input rate. Yes, this looks appropriate. There, now the cycle score is very slightly better. Actually, is this one we want to optimize, or not?
Oh, I've got it, we have
Oh, story. You see, there's a secret extra part of the game, a whole nother area, and that was foreshadowing. The story of this game is actually pretty great, and it doesn't seem like it has one initially, which is only more of a surprise. This level, oh yes, coming are some levels that don't have any great solution. You just need to do the best that you can with the pieces that there are, which is very realistic, actually. One question: does this machine work with the cap on? We're about to find out. Something like this. There. This is perfect. Now just route these. Oh yes, I remember now. There's another there's another step. In that case, this is going to need to be considered later. And the processing for this should happen early. There. Going to need at least one of those. And this all looks correct. Yes. About the leads, those are what's going to need to go in. Only 3 per bottle. And in this case, a checkerboard cutting pattern would work fine. It's going to require something like this. Actually, no, this is the perfect time to transition to the next axis. There. Bring all of this out by 1. There. Perfect. And then this cut is actually simpler than the first one. Yes. And then just feed all of that out. This is the holdup. So this is 8 each time, and we only need 3. Going to route these quite close to the ceiling and directly into the machine. There. And the other part we need, we can route this way, very low to the ground, and eventually to the attaching area. And we're going to need to raise this by only 1 block. And then move everything to the output. Oh, hold on. This needs to move up by 1 exactly. There. And now most of it will just be timing. Like this isn't timing, it's actually margin. Oh, this does work this way, which is perfect. We don't need to consider that now. Oh, it doesn't give it enough time. In that case, what's going to need to happen now is something is going to need to push this off, finally. Or better yet, something needs to allow it through. There. That should work fine. Perfect. Oh, that's not perfect though. That's overflowing. We don't need that many leaves. I think it expected there to be more losses. All these scores are slightly above average. It can be fixed later. Oh, this one. And now we get to fully construct one from scratch. And this is the perfect opportunity to perform stamping yet again. In this case, what would be the best way to do this? This would be quite an awkward shape to stamp, actually. Yes, for multiple reasons. So now, I feel like the correct answer would be something more like a previous method we used. In this case, first additive manufacture, then subtractive. Going to cut out that notch. However, that would asynchronize the feed rates. And that's not great. Another method I still remember is the first way of doing it before before the before times. It would be so much simpler if I had the counter device. I could count the number of inputs and then only trigger on the sixth, every sixth, or every fifth after the first. And of course now I just need to trigger at the correct time, which is difficult to detect. So this needs to detect something twice in order for it to fully engage. The logic for this is already getting complex. I don't like that. Oh yeah, isn't there actually a better way to do this? Why yes, there is. Or so I thought. Hold on. Oh yeah, I forgot you could delete whole blocks at a time. That's useful. There's this method, which detects an overflow and then corrects it. But then of course the problem becomes it doesn't undo itself. So actually, here's another way to do that. There. I forgot I could do it this way. In that case, yeah, this should be much simpler now. And also convoluted. There. Now it's done. And this can be easily extruded. There. Those will need to be rotated. These can be extruded also. And these just need to go to nearly the end when they're attached. Now I just need to route all these parts to where they need to go. This looks correct. Or is it? There. Yes. So what can happen now is this body piece can be dropped in from the top, whereas these can be brought in from the bottom. There. Now it should be visibly apparent what I mean. And then the welders can easily go in here. And that finishes the construction of that part. Only this needs to be delayed by one cycle so that it has time to bring everything in. Now what's this happening? Oh, I see what the problem is. In that case, what could be done about that? That is a pretty sizable problem. in pushing the last one out of the way, that one gets welded to it. How am I going to prevent something like that from happening? Oh wait. Just now noticing the previous plan would not work. These legs need to be welded on in a different way. I might as well completely erase all of this. So I know one pattern that would work. Where the body can go in here and then the two treads can go on either side. Only these would need to be out of the way to give them room. But in a system like that, the tread would need to go in through the sides probably, and then the body would need to go in through the top and be brought out this way. Get rid of the delay, and because we don't need it yet, because we don't know how much delay we need. This appears to be aligned correctly. Perhaps these actually need to be split also. And at this point, this is where this would typically go. Wait, that would need to go there. Oh yes, because those would need to come in from the back in order to make room. Oh, I have an idea, hold on. Just need to convolute the path so that it takes slightly longer to get there. That would block that though. Now try. Perfect. And so now this would trigger this to activate, which at the same time would pull this out. Let's see how this works. Yes. This is in fact exactly what we intended. Oh, that's a problem though. There. On to the next segment. Now to bring in these parts. Just below the ceiling to make room. This part should be the easiest part. Especially since look at that flat plane, perfect for welding. However, that would also mean, in order to do it very well, it would need to be brought in from the side again. That would be in the way. Oh, I know what to do. There. And the other part should be even easier. There. And then every time a new one gets put in, the old one will be taken out. And of course timing. You can delay the first input, but have it be sent in at the same rate, and that would be synchronous. We need to move this to here now. Alright, perfect. Yes. Just convoluted enough to be entertaining, and just efficient enough to not be horrible. And the statistics are average, as I would expect. Yes. Next, this one is going to be convoluted also. Need the two types of biomass to be sorted after the dissection. And of course checkerboard patterns will be preferable. And going to bring this out like bristles of a comb. Yes, these are already prepared. And I can actually stack this vertically, and that would be oh, I see a problem. There wouldn't be any interconnectivity if it was perfectly checkerboarded. That's a problem. So instead, I think waffle iron grid would be the compromise. since true checkerboarding would be impossible in this case. And actually, this would be redundant, because there wouldn't be anything there. There. Waffle irons are more rigid than checkerboards. Anyway. There. I guess all of the red meat is in the middle. The rest is fat. I need to find a way to sort that out. And of course, since there's technically no way of detecting which is which by the machine, it would need to be calculated manually. Also, another thing I just thought about, I guess what we can do, we can even use the eviscerator on our own, or can we? Oh, I don't think we can. In that case, that's an interesting detail. If we can't destroy our own blocks, that would mean that our own machine is safe from destroying itself, firstly. And secondly, we can't have machines that destroy themselves. Which could be seen as both a good thing and a bad thing. I have a new idea, actually. Get rid of all of this. So, what we can do instead is we can target the core here and have that be sent out separately from this part, which is entirely fat. Yeah, like that. And to core this out would be pretty simple. There. And look at that. That's much more organized. In fact, we probably don't even need this, since we can technically just cut down these two. And at this point we can turn it this way. Have that be there. And these two here, vertical. That's too close, actually. Move those back by one. There. And if we waffle iron this also, like before, then these will be cut into perfect strips. And those can be sent directly to the outputs as they are. Yeah, it's just like this. Actually, it'd be better to rotate this first. Yes, should be rotated first, since then the strips would all align perfectly. Just like that. And at this point, that's when this can happen. No. There. The same thing, but rotated. And at this point, these can be sent up and over to the correct output, and these can be sent directly to this one. Oh yeah, the balancing at the end. Yeah, that would be the last portion that has any complexity. That's not high enough. There. Now see how this works. Incorrect. And we don't even need to split these, even. Oh, that's a problem. Need to sort these out, since they don't technically qualify. Yeah, that's a problem. One small error. In that case, these sides might be the ones we discard instead. A lot of waste so far, but it reduces the complexity, so it should be fine. And look, now the two outputs are perfectly balanced. Yeah, they both get a multiple of 2. Yeah, that should be fine. Now the only thing left to think about is the balancing. And that's actually the easiest part. There. Now it's done. Complete. The cycle score looks better than one would perhaps expect. And the final level of this section. Coming close to the end of the game, actually. Most of the game is in the first sector. Okay, so for this one, we're going to need to make one of those things. And moving very slowly towards it, we can see going to need the 2 front guns. This really doesn't look large enough to fit anyone. And the thrusters, 3 long, and the hull. Fortunately, these 2 are right here, and so are very simple to construct. Hold on. They should be rotated first. Into the correct orientation for that. And then put together. And there. These are both ready now for the second stage of construction up here, after we pull in everything from down there. Yeah, perfect. In fact, we could probably weld these together as a pre-processing. In fact, that's exactly what I'm going to do. Oh, I see. Hold on. looking into the future and seeing what possible problems I could have. There. Now that should work perfectly. If the timing was correct, that is. And if this was also correct. And then I can just feed this out. The number of times that I've said this should work perfectly and then it has 50 flaws. Well, I'm not going to stop using that phrase now. It's already too late. The construction for this part should happen in here to keep everything organized. That needs to be 6 by 2 by 2, and that's simple. And then those two should clamp onto the sides. And keep this as far out of the way as possible. But not so compact that it's difficult to work on. That's worse. Worse than the problem it was trying to solve in the first place. And those are in the correct orientation. These can be stamped actually, pretty easily. I should lower them first so that they're not so difficult to work with. There. I think I know of a new method for doing this. First, move everything down. And now... interesting. Let's see how this works. Not well, actually. What if instead we used an older method? First, make these, and then after that, make these. In this direction, not the other one. And then finally, glue those together in stacks. Well, it works. Good enough. This should be moved up by 1. There. And that works fine. Now, about those things. Oh, I know how to do that. That's pretty close to the wall, though. These should really be consolidated first before feeding in. There. And now... they'll be pushed in when they are ready to be pushed in. Indicated by a detector of one of these, although the spacing needs to be calculated first. Oh wait, these should be brought in to closer to where the thing already is, not the other way around. Like that. There. That interferes. So instead of, at that point, one further ahead. One less of these. Two less of these, actually. And not nearly as much margin as I thought there would be. First, align this correctly. There, and then move it in like that. And of course, they should all be moved down so that they're being pushed in from the side. No, that wouldn't work at all. Looking at the model, the perfect place to weld would theoretically be the top here. But that's actually incorrect, because that's where these needs to go in from. Once this is detected by this, actually, no, by this from the top, so that it's easier. These should be pushed in. And then we can pause at exactly the time that would happen to take measurements. So, I know exactly how this can be welded together. So, either we can have the welders be first the two on top here, and then from the front here on these two. No, because this one would be blocking that one. It wouldn't be blocking if it came in from an angle like this. Oh, I have an idea. What if this was moved back to where it was, firstly? There. Fully back to where it was. Here. Now, at this point, what we can do is have them come in from the side like I said originally, but this time, since they're coming in from so far away, they won't be blocking this part from coming in either. Which also means we can move all of this down to the correct level, which is here. There. And this needs to be moved down to where it's supposed to be. There. Now the welders can just go on the top like this, without any problem at all, that I can see. And now we can use this to then move this completely out of the way. And then we can move it to the elevator here. It can bring it up to where it's supposed to be. There. See how this goes. Probably poorly. There. Not that bad actually. The worst part is waiting for this to come up, because it's so slow. So, at this level... Now, just to quickly test how that would work before proceeding. I wish there was an even faster forward. A quadruple speed. I see. In that case... actually... this would need to go this way. In one of these two spots, we'll find out which. Just going to grab by the thruster, since that's the part that's protruding out the furthest. The closer one is correct. There's going to be a lot of waiting in this, I can already tell. And then we're going to need a huge delay line here in order to make sure that everything is correctly in phase. Or not in phase. What would that even be? I'm probably using the wrong terminology because I can't think of the correct terminology to use at the moment. While I'm thinking about that, I'll just fast forward. In phase is when two actions happen at the same time. That's technically synchronized, or synonymous to synchronized. What I'm thinking about is, technically also synchronized, since the beginning of both would be... Anyway, we find out that this works now. Or we're going to need to have this delay line be installed now. I don't know how long it needs to be, so I'll just figure out. And... There. That system looks good. I know what, instead of a delay line, we could just have this be manually synchronized with a pusher. Right here, that detects incoming. There. This should probably work. No longer needing a delay line is probably worth it. The extra small amount of logic. Oh, hold on. And at this point, we can have it align the rest of the way. There, now it's done, I'm pretty sure. Mostly sure. It's very important for these large projects for you to break it down into smaller projects and then modularize it. Because if you don't, if you make it into a monolith, it's going to be a complete mess, and you're not even going to know what went wrong. Oh, thankfully it fixed itself. I thought there was going to be a problem with alignment, but no, it's fine. Overall, I don't feel too badly about how this is now. The cycle score is trash, but everything else is fine. Enough of this. It's already been long enough.